All right, so let's take a look at solving one-step equations. We call them one-step because there's only one opposite operation that we need to do in order to solve for the variable. Solving for the variable means telling me what value of x makes the equation balanced and makes the two sides equal to each other. So what can I replace x with so that that number plus 12 gives me 5? And the strategy we use is called opposite operations. So whatever operation is happening here, I'm going to use the opposite. So here, x has 12 added to it. So the opposite of adding 12 is subtracting 12. So I'm going to subtract 12 from both sides of the equation. Whatever you do to one side, you have to do to the other. That's the golden rule of math. So x plus 12, I'm going to, and then on the other side I have 5, so I'm going to subtract 12 from both sides. And what ends up happening, 12 minus 12, that's 0. So all I'm left with on this side is x, and then 5 minus 12 gives me -7. So that's my final answer. If I wanted to check, we do something called a left side, right side check. I look at my original equation and I look at, okay, well, what did I have on the left side of the equal sign? On the left side, I had x plus 12, and on the right side of the equal sign, I had 5. Now I can substitute the value of x that I just found, which was -7. I substituted, instead of x, I wrote -7. And then I can simplify. So -7 plus 12 gives me 5. That's what I have on the right side. So I can say, therefore, left side equals right side. That means I did it correctly. I found the correct value of x because when I put it back into the equation was balanced. It was the same on both sides. If you did that puzzle warm-up, it would mean that the balancing scale was straight. They were the same on both sides. Both sides equal 5. Okay, let's look at this example. So here I have x minus 17. I'm trying to isolate x. I'm trying to get it by itself. So I'm looking at what's happening here. I have 17 being subtracted. So I need to do the opposite. Instead of subtracting 17, I need to add 17 to both sides. So I'm going to rewrite it. And what I like to do, it's important to line up your equal signs. So as you're copying this into your notes, make sure your equal signs are lined up. So on the left side, I have x minus 17. And then on the right side, I have -21. So what I'm going to do is I'm going to do the opposite operation. So I'm going to add 17 to both sides. And then simplify. So x minus 17 plus 17, so these are opposites, so they're going to equal 0, so I'm just left with x. And then -21 plus 17 is going to give me -4. Make sure you're reviewing your integer operations if you're still uneasy with that. Just like I did before, I can check to see if that's correct. You don't need to do a check for every question, but here and there, just to make sure you're on the right track. It's good. It's a good skill to have. So on the left side of the equal sign, I have x minus 17, and on the right side of the equal sign, I have -21. So on the left side, I'm going to substitute that -4 that I found. And -4 minus 17, so I'm adding a negative number, going further into the negatives, and I get -21. So left side equals right side. And these left side, right side checks you'll need for next year, so make sure that you are practicing that. Okay, so in C, I have 6t is equal to -18. That means that the t is being multiplied by 6. So the opposite operation, the opposite of multiplying, is dividing. So I'm going to divide both sides by 6. And I like to write it like this. Divided by 6. Divided by 6. 6 divided by 6 is 1. So I'm left with t equals Negative 18 divided by 6 is negative 3. And that's my final answer. I can check this one too. So on the left side of my original question, I had 6t. And on the right side of my original question, I had negative 18. So instead of t, I can substitute the negative 3 that I found. And I get negative 18, which is the same as here. That means I did it correctly. You must write it like this. Left side equals and then right side equals. You can't write it as a single equation and then substitute. It has to be done like this. So get into the habit of doing it like that from the start. Okay, over here, D, I have m over negative 3 is equal to 12. So that means the operation with the variable is it's being divided by 3. So the opposite of dividing by 3 is multiplying. Sorry, it's being divided by negative 3, and the opposite is multiplying by negative 3. So I'm going to multiply both sides by negative 3. The reason I do that is that now I have negative 3 divided by negative 3. These two are going to cancel out. So all I'm left with is m on this side. And then on this side I can multiply, so 12 times negative 3 is negative 36. And I won't do a check for this one just because of space. Last question, x squared is equal to 81. So the opposite of squaring a number is square rooting. So I'm going to take the square root of both sides. The square root of x squared, the square root and the square actually cancel out, and I'm left with x equals, and the square root of 81 is 9. And that's my final answer.